So I'm Saeed, and I'll be taking this session. So the first thing that I'd like to do is just to introduce myself. So this is I'll be presenting from a Jupyter notebook. So let's just start that quickly. So I'll be talking about just as an introduction to Python for finance. And I'll also be talking about the quantitative developer certificate as well towards the end, which I'll be one of the lecturers on, and it's a WBS course over the coming months. So just a bit about me to begin with. So I've been working in foreign exchange markets for around 15 years. So I started at Lehman Brothers, and later I was at Nomura as well as an executive director developing systematic trading strategies. And throughout that time, I've been very keen in terms of trying to code as well to automate my analysis, doing a lot of statistical analysis. So initially, I did a lot of work during my career with MATLAB, but over the past few years, I've switched over to Python. And pretty much exclusively now I end up using Python. Also a bit of Q. I've started to learn Q as well. So I think okay. I think I've got a question from Elvis. So it says that you can't hear me. Okay, so I think the issue probably is not at my end. So okay, apologies about that. Potentially, you might need to turn up your volume or something like that. So just getting back briefly to the lecture. So I've been using Python for a couple of years now, and over that period, I've developed several open source libraries, and I'll talk a bit about them later and also do some demos as well. And all the open source code that I'm showing you is available to download on GitHub. So please feel free to have a look at the code later. So first of all, I have FinMarketPy, and that's a library for backtesting trading strategies written in Python. So I use that a lot for my own work, and I know a lot of people also use that in the trading community as well. There's also then FinDataPy. So that's a way of downloading market data from many different data sources. So the data sources include things like Bloomberg, if you have a Bloomberg terminal, but it also includes a lot of other sources which are free. So in particular, there's a way of downloading FX tick data through it from TCAPI. You can also access Quandl as well through it too. And the idea is it gives you consistent interface between the various data sources. There's also ChartPy as well. So that's a wrapper essentially for doing visualizations in a nice quick way. And in terms of the number of users, FinMarketPy is actually one of the most starred libraries on GitHub for Python backtesting. And I've also recently open sourced a library for transaction cost analysis called TCAPI as well. I'll also demonstrate that later. Aside from a lot of the stuff that I've done on Python and in terms of developing trading strategies within currency markets, I've also co-founded the Talesians, and they're a partner on the QDC as well. So Paul Billicon, the founder of Talesians, will also be teaching on QDC as well. At my current firm, QMacro, I'm focused on doing quant consulting in macro markets. Again, kind of focused on trading strategies, but also a lot of work around alternative data as well. And I presented my research at a number of official institutions, so including the Fed, also ECB, IMF as well, and Bank of England. And I've also presented at many major quant conferences, including a few organized by WBS as well, and they've been very enjoyable events. So, and I hope to meet many of you in person at a future WBS quant conference as well. I'm also the author of Trading Talesians, so what the ancient world can teach about trading today. I'm also very excited about a book that I'm currently writing with Alexander Dennett, the Book of Alternative Data, and that's going to be published by Wiley in July. So basically looking at unusual data sets, things like machine-readable news, satellite imagery, and then giving use cases, but also talking about a lot of the challenges associated with alternative data. Is also available now to pre-order on Amazon. And one thing that I would say is, given that I'm sure a lot of you got questions, feel free to put questions on the chat, and I'll be checking the chat periodically to see if I can answer them as well. So I'll do a thorough Q&A at the end, but if you do have any thoughts throughout it, feel free to jump on the chat. But in particular, towards the end of the hour, feel free to put any questions you have on chat. I will be periodically checking it. So I'm just peering over now, just every so often, to look at the other screen with the questions. So in terms of the outline for the talk, I gave a brief introduction to myself and also some of the Python work that I've been doing. I guess there's several parts to the presentation. So first of all, why use Python to analyze markets? Then we'll go into a discussion of some of the Python libraries that you might find useful for using financial analysis. So if you're already familiar with Python, I'm sure quite a few of the libraries you may have heard of, but I'm sure that at the same time, there might be a couple that you've not heard of as well. So each time I give this presentation, I always add a few extra libraries. In most of these cases, I've used the libraries personally, but even then, even if I haven't, they're kind of on my to-do list of libraries basically to look at. And also I want to try and make it a bit interactive. So I'll also be giving a few Python demos as well towards the end. So that's usually the opportunity for my computer to crash or something like that. But I think we're going to try and take the risk there. So I always enjoy viewing demos of code. So hopefully that will be useful. Just some very simple stuff. So in terms of downloading market data through FinDataPy, and also I'll give a demonstration of my transaction cost analysis library as well, showing how you can use it. And all this has been written in Python just to give you a insight into some of the things that you can do with Python. So I guess the first question is, and I guess this is the crux of the presentation, it's a question a lot of people have been asking themselves as well. Why do we want to use Python to analyze financial markets? I guess there's many different ways you can analyze markets. So one is from the perspective of someone developing trading strategies like myself. It could be if you're doing risk calculations. It could be if you're pricing options. So there's many different variants of the types of things that you'd want to do with analysis of market data. But I think one thing that is common across all these types of analysis, and I'd say even outside financial markets and data science more broadly, is we often have conflicting objectives. So on the one hand, we want fast computation, the thing to execute very fast. But then we also want to have development time, which is actually relatively short as well. So it's all very well something executing quickly, but then if it takes too long to develop in terms of coding hours, then potentially you'll end up actually losing out because of that. So it's the key point that I want to kind of point out there is that fast doesn't just refer to the computation, like the execution speed on your CPU. Also, that refers to the amount of time that it takes for you to actually code up that algorithm as well. So from this perspective, if you're purely looking at execution, something like C++ is obviously going to be very fast because it executes down into machine code. Also, Java doesn't execute, it doesn't go down to machine code. It's basically executed on Java virtual machine, but that will still generally be quicker, I would say, in many cases than Python. But one thing is that it's going to generally take more time to develop your code, especially if you're using something like C++. Java does make life a bit easier for you. It's got things like garbage collection and the likes, but still I would argue that Java will probably take a bit longer than Python. There's other possibilities if you're doing statistical analysis. So R has many statistics libraries, but I would argue that whilst it's kind of like a nice language, it can be a bit slow and potentially might not be suited to as big systems as Python. Julia is a newer language, and it's touted to be very fast and kind of offer a lot of the advantages of Python. But by comparison, I'd say with Python, it doesn't really have as many supporting libraries. It is true, though, that you can call Python code from Julia, but if you end up calling all your code is Python from Julia, it kind of defeats the point of using Julia. Q is also a great language, and it can be used to backtest trading strategies within KDB, but it can be tricky to use for other tasks, potentially. So it's ideal for some use cases, but maybe not so much others. So Python is kind of is a different beast. So we can see Python as being a bit of a compromise. So it's not going to be as fast as something like C++, obviously. I think I've got a question saying, can I show the slides full screen? I think I'm sharing my screen full screen. Can everyone see my slides okay? Okay. So essentially, Python can be seen as a compromise language. It's more of a general purpose language compared to something like R, which is more geared purely towards statistics. At the same time, it's quicker than R. It's probably at the same time going to be slower than Java or C++. At the same time, we can actually use it to engineer large systems because it supports object-oriented programming as well. If you're a fan of that type of thing, I like doing stuff in the object-oriented way. You don't have to do that in Python if you don't want to. There's also many libraries that you can use to play with data with Python. So I'm going to be addressing a few of them later in the presentation. And also Python can be a nice way to bind together and glue code written in many different languages. So you can, for example, write a lot of your analysis, say in Q, if you're using a massive tick data set, but then you can use wrappers essentially to call Q from Python. So you can end up mixing and matching between them, doing some of the analysis in Python, where the data set is a bit smaller, maybe using Q for kind of the massive tick data set. And also you can call C++ libraries as well from that perspective. If you want to, you can also write code in using Python, and this can be used to speed up specific bottlenecks in Python. And essentially what it does is it ends up being like a superset of Python. And the idea there is you can write Python-like code, which actually ends up converting to C and then down into machine code. So if there's any particular bottlenecks or anything like that, you can use Python to speed them up. There's also other nice libraries as well, such as Number, which I'll talk about later again, that you can use for speeding up specific bottlenecks. And arguably, you could say that actually computation is getting cheaper all the time, especially with the cloud. So potentially, you can actually solve a lot of these issues if you distribute your computation using the cloud. So I'm going to talk about a few useful libraries for data science in Python. As I've mentioned, a few of these, I'm sure if you've already used Python, you might have heard of, but I do hope there's going to be a few there that you've found as being a bit different. Okay, so this is kind of the core data science, basically data libraries in Python, known as the Scifi Stack. So we have IPython, so it's an interactive console for Python. So I'm just delivering the presentation now from a Jupyter notebook. So you can either view it as slides like this using the Rise plugin, or we can just go back and view it as a notebook directly like that. So you can mix and match between the two different views here. Then we have NumPy. So this adds high-level operations on matrices. So using matrix multiplication, vector operations. And this removes a lot of the problems associated with Python. So in particular, trying to do for loops in Python are very slow. So if you're attempting to, say, matrix multiplication with Python, generally try and avoid using for loops. But the idea if we use NumPy is it will allow us to do these operations in a vectorized way. And typically, the low-level code will end up being C or Pythonized code as well. So it will be a lot quicker than actually just doing it in Python as well. One library that I end up using probably most of all is Pandas, so time series library. So in financial markets, time series is the kind of the core unit for data. So if we think of prices, they're time series, dividends, etc. There might be price series. So everything roughly ends up being associated with some sort of time series. And this actually grew out of the work by Wes McKinney at AQR Fund where he was working. And they end up allowing the library to be open source. And it provides many common operations for time series. So a lot of them, if you've done any sort of analysis before and you've not had access to libraries like Pandas, typically you've had to write them yourself in practice, or someone in your firm has basically written them. So this includes operations like aligning time series, joining time series, And also there's a lot of computations as well. Like if you want to do rolling operations like moving averages and the like, you can also do that too. There's the Scifi library. So this has operations for numerical analysis and optimization, and SymPy for doing symbolic operations, like if you're doing integration, etc. And I've just put some of the logos here below for some of the various libraries. Okay. One key point about any sort of data analysis is not only the computation itself, but the ability to actually present that not only to yourself, but also to others. And in terms of visualization, Python's followed on from R, which has great libraries like ggplot, to also offer a lot of capability when it comes to visualization as well. So here I've got a question. So would you rarely use the standard Python lists? It depends. There are use cases where you might wish to use lists. But what I would say is if you're trying to represent, say, the time series, you probably wouldn't want to use a list. You typically try and use a NumPy array. And the way that pandas works is essentially that the values within that time series are essentially NumPy arrays, and also the dates as well. So the pandas data frame is essentially a collection of various NumPy arrays, essentially. But lists do have their uses as well. So I wouldn't preclude it, but there are, I'd say, in many cases where you're dealing with very large data sets, probably NumPy is probably better. So in terms of visualization, there's quite a few different libraries. So Bokeh is a JavaScript-based library. So here you can create interactive visualizations you can open up in web pages and use. Matplotlib is probably the most well-known visualization library in Python. The interface can seem a bit complex, but it is a very flexible library. And there's also lots of nice wrappers as well to use on top of Matplotlib to make it easier to use. So in particular, there's a library, Seaborn, which basically automates the construction of things like violin plots or distribution plots. So it basically simplifies a lot of the hassle that you might wish to, you might get impacted with Matplotlib if you end up doing some sort of complicated chart. If you just end up doing a bar chart or something like that, it's not that difficult, but it's more in terms of more complex visualizations. Plotly is a library that I end up using quite a lot personally. So in a sense, it's a bit like Bokeh because it's JavaScript based. So again, you can load it up in web pages and kind of zoom in and out of plots. And also it allows the sharing of your charts to the web or in a private environment. But these days, actually, most people end up using Plotly in an offline way. So you don't need to share your plots with anyone else. And also it's accessible from many other languages, including R and MATLAB. So typically the way that Plotly works is you end up constructing your plot as a JSON, basically, and then the JSON is given over to the underlying JavaScript Plotly library, which ends up rendering it. But it does have a Python wrapper, it also has an R wrapper, MATLAB wrapper, etc. So you don't actually need to know JavaScript to make it work. There's also VisPy, which is GPU accelerated plotting as well. This library is probably not as mature as some of the others, but if you're doing something very complicated, it can be quite useful, like if you're plotting millions and millions of points. Other libraries which I've used more recently, if you're plotting very large data sets, includes Data Shader, and there's also a library which acts as a wrapper for many of these, which I've developed, ChartPy, which is a wrapper for Matplotlib, Plotly, and Bokeh, and another similar wrapper called HoloViews as well, which tries to make them more generic. In terms of, I've just got a question about use cases, comparing it to Power BI. So I would say the difference, things I haven't used Power BI myself, but I've got this question asked by a lot of people. Why don't we just use Power BI to do reports? I would say that potentially you might have more flexibility if you end up using Python. That's the key thing. So it really depends upon your use case here. Like I would expect that some of the visualizations that you can do in Matplotlib, you can definitely do in Power BI if they're simpler plots, but then you get more customization over the charts. And typically, if you want to do a report, you might end up combining these visualization libraries with something like Excel Wings. which basically allows you to call Python within Excel. And I'll actually show you illustration of this later using my TCA library, TCAPI, to basically show you how to do a report in Excel. But that's a good question, because I've been asked that quite a few times before. Why would I want to do Python instead of Power BI? So I think one thing would be flexibility. And also it's all open source as well, whilst I think Power BI is not. So that's something to be thought about. So one of the big buzzwords, obviously, at the moment is machine learning, and also, I guess, statistics, which is kind of the old-fashioned way of talking about machine learning. And there's many different libraries for statistics and machine learning in Python. So if you're looking at probabilistic programming in Python, so Thomas Vicky, he's written PyMC3. And one library that I've ended up using quite a bit in my teaching is scikit-learn. It's kind of the most well-known library in Python for doing machine learning. So it's got lots of simpler models, which I'm sure many people are familiar with, like linear regression, etc., logistic regression. But then it also has kind of more, I'd say, more machine learning type libraries. Although I guess collectively they're all known as machine learning, so things like SVMs and so on. We also have TensorFlow, so this is a library for machine learning which has been open sourced by Google a few years ago. It's become very, very popular, and it now includes Keras, which is a high-level wrapper as well, which makes it slightly easier to use. If you're particularly looking at kind of more econometrics, you can also look at quant econ as well. And also check out a time series analysis library built by Paul Billicon as well, Talesian's TSA as well. So he's been working a lot over the past few years on that, and it includes things like stochastic filtering as well. So I just got asked the question here, what is your favorite machine learning tool and why? I'd say probably the one that I've ended up using most has been scikit-learn. So typically the types of models that I end up developing end up being relatively focused towards simpler things like linear regression. So if you're doing stuff like that, I would say scikit-learn is absolutely fine for that. If you end up doing kind of more complicated things, maybe things with neural networks, maybe you might want to consider some of the other libraries. But I would just say scikit-learn just because I found it easy to use. I wouldn't say that I've used TensorFlow massively, or PyTorch, I should have probably put on the list. I've not used that massively per se. Typically, when I've used things like TensorFlow or PyTorch, it's been through wrappers. So I've used, for example, transformers, which is for doing natural language processing. Typically, a lot of the pre-trained models within that have been trained using TensorFlow or PyTorch. So I've used it from a wrapper's perspective. In terms of using TF-Learn as a higher level wrapper for TensorFlow, I've actually not used that. So it's just a library that I've read about. So I can't say specifically why you would use it over Keras, but Keras seems to be the most popular one, and it's also part of the TensorFlow distribution from version 2 and above. So I've got a question here. I've got a question in terms of data download for visualization and which type of database do you use? SQLite is probably the easiest database to use because essentially it sits within the same process. You don't need to start a separate process for it. So if you're the only person using a database and you just want to store it in a flat file, SQLite is actually fine for doing that. Typically, the library that I end up using most for storing data is Arctic, and essentially Arctic is a wrapper on top of MongoDB, and this has been open sourced by the hedge fund man AHR. And basically the use case for this is you can store massive time series in MongoDB in a compressed way, and it's very easy to fetch data from that. You can't do much in the way of on-database computations that you could, for example, use SQLite for. But if you're just fetching data, that's fine. Another database that I've started to use is KDB, which uses the Q language, and part of the QDC course will actually be taught by Paul Billicon on Q, and he's actually one of the co-authors of a new book on Q. So I definitely recommend having a look at KDB and the Q language if you end up using high frequency data sets, which are time series. In terms of reinforcement learning for portfolio optimization, I've seen some work on that, but I can't really comment upon that myself because I haven't done that necessarily myself. So I can't tell you whether that makes money or loses money. But I know a lot of research is going into that area. One thing that I would say in terms of reinforcement learning is that financial markets are not so much a closed system. So reinforcement learning has been very successful in games where you have very strongly defined rules like chess or Go, etc. But in financial markets, I would expect it to be a bit more difficult to get it to work. But I'm by no means an expert in reinforcement learning to tell you whether it's good or bad. Just my own experiences. So here's a section on computation and parallelization. I touched upon this a bit earlier during the presentation, saying that a lot of the reasons why people some of the negative points with Python are basically that it's not as fast as other languages which are being compiled. So Scifi is kind of one of the earlier examples of ways to get around it. So essentially Scifi is, as I mentioned, is like a superset of Python. So you can, a lot of the operations that you can do in Python, you can also do in Scifi, and it also adds additional functionality. So for example, you can also put types as well. So if you're doing, let's say you're doing a for loop in Python, and it's very difficult to vectorize, provided you're dealing with things like NumPy arrays or doubles or kind of fairly standard Python types, you can end up actually Scifinizing the code and converting it to C, and then converting it to machine code. So number is slightly different here. So you don't need to necessarily pre-compile your code. It actually just does this at runtime, essentially. And also the thing with number is it also gives you the ability to target different types of processors. You can target either CPU or also GPU as well. I've only used it with the CPU. I've not really used it too much with the GPU. I think even with the GPU, you probably need to understand a bit more about how GPUs execute their code to do that. So it's not a case of just putting the decorator at the top and it will suddenly speed it up for the GPU. You still need to do a bit of work. But arguably, I would say it's probably easier to use number to do this rather than doing low-level CUDA coding in C, potentially. Another thing that you can do is, aside from speeding up specific bits of code, you can also try to parallelize your operations. So threading is kind of the simplest library for doing this. So if you have an I/O heavy operation, let's say downloading web pages, threading might actually be an easy way of doing that. In this instance, I've got a question here saying, am I scrolling down my slide or not? So can everyone see my slide on computation? Is that visible for everyone? I hope it's visible. Okay, it's visible. Okay, that's great. So if it's an I/O heavy operation, you can use threading. The thing is here, it's not actually executing the operation on different cores. So if it's I/O heavy, like downloading web pages, reading from disk, it's okay essentially. But if you're doing some heavy duty computation, which actually requires processing, let's say, I don't know, matrix operations or something like that, then potentially threading is not necessarily going to help there. So here you might consider something which actually kicks off new Python processes and does the computation. So one of these is one of these libraries is multiprocess. There's also multiprocessing as well, etc. as well. There's a bit of overhead associated with creating new processes, though. There's also Celery as well. So this is a synchronous distributed task queue. And here the idea is you can create workers to do your computation. And these workers can be on the same machine. They can be across a different cluster. And also you can specify the types of workers. So you can say if you want them to be kick off new processes or threads as well. You also have async IO for doing asynchronous IO operations. So this is basically kind of sits on, it's a bit of more of a higher level library as well. We also have Dask as well. So this is like a pandas-like library. But the nice thing with this is that you can end up addressing absolutely massive data sets. So the issue with pandas is, let's say you have a data set which is 100 gigabytes. You can't just load that into memory unless you have like hundreds of gigabytes of RAM, essentially. So in this instance, the way that Dask will work is actually partitions the data frame, and it does the batching in the background. So you can just pretend as though it's a pandas data frame, and it'll actually batch the computations in the background for you. There's also another similar library as well that I've been using called VAX, V-A-E-X. And this again works with very large data sets, and it's actually super quick for certain operations. It's not quite as well featured as Dask, but I would definitely have a look at it if you just want to do a quick visualization of a massive data set. So I've got a question here regarding new types of data in terms of alternative data. Are there file formats which are not compatible with SQLite? So the thing with something like SQLite, or I say SQL databases in general, are that they expect your data set to be structured. So essentially you have predefined fields. They can be timestamp, price, etc. The difficulty with a lot of alternative data, when you get it to begin with, it tends to be unstructured. So it's not going to be of the same format. So if you think of a lot of unstructured data starts up as web pages, well, web pages often don't have a common sort of format associated with them. So you have the body text, maybe you have the timestamp when you collected the data from the web page, but it's not ideally suited, at least in the very raw form, to be placed in a SQL database. Maybe once you've structured it and you've added various meta tags associated with it, you can put it into that database. So potentially you can try using maybe a NoSQL database, something like, I don't know, MongoDB or something like that to store the data. If it's a massive data set, there's also other things that you can potentially store it in, something like Spark as well, if it's a massive data set. So here, I've got a thing here saying which one corresponds to concurrency. So I would say here, you can do an element of concurrency with all these different libraries, essentially. So it just depends upon what you want to do in terms of concurrency. So all of these support some different type of concurrency, essentially. So have I tried Modin as an alternative to Pandas? I have tried Modin. Basically Modin allows you to, it basically parallelizes a lot of the operations on Pandas. So if you want to read a CSV file, it will generally be a lot quicker using Modin compared to Pandas, because essentially it will use several different cores for that operation, which I think Pandas typically doesn't do. So I've found it a lot quicker for reading CSV files, Modin versus Pandas. The version of Modin I was using was 0.54, so it's not the latest version. So maybe the later versions are better. But what I did find is that on other operations, it didn't necessarily seem to be quite as quick as reading CSVs. And also Modin, I don't think it doesn't work with Windows as well. So I realized we should be using Linux, all of this stuff, but in practice, in many instances, we still have Windows machines as well. So Modin is worth a look, but I don't know, I found it not as it basically only speeds up a small number of operations. It doesn't speed up as many things as I hoped it would. But I'd be interested to hear about other people's experiences using Modin. So one thing that Python has a lot of is libraries for doing natural language processing and dealing with text. So kind of, I say the oldest of these libraries is NLTK, the Natural Language Toolkit. And it's an absolutely huge library. So I've been using it for a few years, and I think I've only barely done maybe 10% of the functionality with NLTK. It also comes with many different word corpora as well. So one's particularly relevant to finance. It's got, say, all the Reuters news articles in 1987. It's also got novels, etc., in the word corpora. But it's generally, if you want to do natural language processing, this is probably the first place to start. I wouldn't call it doesn't have like cutting edge technology in it, cutting edge things, but it's definitely quite a nice library to start with, doing word tokenization, splitting things into sentences and that type of thing. You also have Spacey as well. So it does a lot of tasks associated with natural language processing, things like extracting entities from text. And also it tends to be quite fast because a lot of the code there is in Scifi. So it's worth having a look. One thing you might find with NLTK is the API can be a bit difficult to use to begin with. So often I end up using text blob. So that's just like a high-level wrapper for NLTK. There's also other libraries as well, like Stanford Open NLP. I haven't used that, but I've heard good things about it. A library that I've been using more recently that I haven't added to the list is called Transformers. And this is by the company called Hugging Face. And this is available on GitHub. And this has a lot of pre-trained models on it already. So a lot of different types of word embeddings like BERT, and you can also contribute your own pre-trained models to it as well. And you can use it to use kind of more state-of-the-art NLP libraries, potentially. So that's it. That's definitely something worth doing. It's something I probably should have added to the list. In terms of just extracting text, before you do anything in terms of natural language processing, you need to get the text. So if you're trying to get it from web pages, I'd strongly recommend looking at tools like Beautiful Soup. So these essentially help you extract the body text you're interested in, remove all the HTML tags. There's also another library which uses Beautiful Soup called Newspaper that I've been using recently. And for websites like BBC, etc., it's quite impressive at how accurate it is at actually taking the body text of those articles. A lot of the cloud vendors also have their own NLP services as well. So you'll give it a text and then they'll come back with output, like what the sentiment is, what are the named entities, etc. in it. And these include IBM Watson, Google Cloud, AWS, and Azure as well. So that's another way that you could do NLP as well. Just use it as an external service. There's also Refinitiv, have Calais as well, who do entity detection. And a lot of data sets these days, they come with a lot of the metadata associated with the text tag to it. So things like, again, like sentiment. So typically the data provider has already done a lot of NLP on the text. So if you think about a lot of the newswire companies like Bloomberg and Refinitiv, they basically have machine readable news, but they don't just give you the machine readable news in a raw format. They also have it tagged with many things like the timestamp, the tickers it's associated with, and the like. So they've basically done quite a bit of the NLP before they give it to you. So essentially the data set is a lot more structured than it is from a raw form. There's also a lot of front end that you can develop in Python. So Flask is basically like a mini framework for doing web-based applications. Dash, which I'll just show you soon in a demo, basically is a wrapper on top of Flask. It makes it quite easy to create web dashboards. If you're using Excel, Excel Wings is a great open source library. So here, basically, you can use Excel as your GUI, your front end, and in the back end, you have Python operations. And a few kind of miscellaneous libraries as well for working with web data. So Selenium, which is a web browser emulator, Scrapy for doing kind of automated web scraping, and Twython if you want to read text from Twitter. One thing I would say with Twitter is the free version has quite a limited bandwidth. So if you want to end up downloading loads of tweets, you basically need to pay for a subscription for Twitter. So a key part of any sort of analysis of financial markets is data. So we kind of touched upon this in some of the questions. So how do you store your market data? So I was mentioning Arctic. That's a very efficient way to store pandas data frames in MongoDB. There's also a nice new library that I've been looking at called PyStore. And it's kind of similar to Arctic, but instead of using MongoDB, in the backend, it just stores the files as compressed Parquet files instead. So that's another option if you want to store very large data sets. If you want to download market data and using Bloomberg, there's BLP API as a package. Also, Quandl have a package too. And my FinDataPy actually acts as a wrapper on both of those. If you're using KDB, there's actually several different wrappers for accessing it from Python. So one that I've used probably a bit more than the others, and I found it quite easy to get it to work, was QPython. And another database is kind of more like a key value store is Redis, and you can access that from Python as well. So I'm just going to talk briefly about libraries for financial markets specifically. So I'd like to basically talk about the parallels between data science problems and also developing trading strategies. So I want to outline a few of the generic steps which we might take when we're solving a data science problem. and then basically try and look at them from the perspective of developing a trading strategy, which is what I typically end up doing most of the time. So the first thing is we want to form a hypothesis, whether it's a data science problem or for a trading strategy. We then need to find the data. So typically for developing a trading strategy, this is often from the market, so market data, but it can also be alternative data sets. Then with a hypothesis and data, we use statistics to check our hypothesis. So this is basically backtesting a trading strategy. And then we want to present our findings, usually with a sort of element of visualization as well. So what I've done is I started creating Python library PyTalisi. So it's actually more than 2 years ago now, but it ended up being a really big library. So I ended up splitting it into several libraries and rewriting it. The main reason is that often a lot of the popular open source libraries tend to be rather focused as opposed to doing absolutely everything. And I've split them into 3 different libraries now, which have been going for a couple of years. So FinMarketPy, which as I'm mentioning, which is basically for backtesting trading strategies. FinDataPy, and I'll show you a very brief demo of that shortly. And also ChartPy for basically doing charts. And the idea with ChartPy is it lets you switch between, say, using Plotly and Matplotlib just with a single keyword, essentially. So how often do you deal with really big data? So it depends what type of project that I'm doing. So I'm not sure whether the data I've been dealing with ever has been what people would call very big data. So I guess the biggest data sets I've probably dealt with are probably a couple of 100 gigabytes. So whether that's big data is another question. I would probably say when people think of big data, that's probably something when you're talking, I don't know, terabytes, petabytes, etc. But kind of the biggest data sets that I've used are probably a couple of 100 gigabytes. And typically the way that I've done analysis on them has been through batching using pandas. But more recently, I've actually started to use things like Dask instead. So I'd say the key points to developing any sort of library is abstraction. So this is kind of computer science 101, I guess. So particularly in Python, we have a lot of choices of underlying libraries that we wish to use. So which market data do we want to get? Do we want to use BLP API? Do we want to use Quandl? Do we want to use Refinitiv? What type of visualization library do we want to use? Is it Bokeh, Plotly, Matplotlib? So the idea is you want to abstract away the underlying library. So we just have higher level code, essentially. Otherwise, our code will end up extremely messy if we end up having low level details sprinkled through all our code. Essentially, whether it's financial markets or just data science more generally, we want to separate out the plumbing, the low level details like loading data, etc., and plotting it away from the underlying data science problems. And particularly from the perspective of financial markets, if we're a trader, we can concentrate on developing the trading strategy rather than continually trying to understand the underlying API of things like loading market data, visualization, caching, distributed computation, etc. So our objective, if we're traders, is to understand the signal, basically the buy, sell. That's the key point. And by partitioning our code in this way, it makes it easier to maintain and update. And also we can add underlying libraries, new underlying libraries when they become available. So if there's suddenly a really nice plotting library that we never knew about, we can just slot it in and hopefully it won't need us to rewrite the whole of our library. So here, I guess, the question is, do we want to have our code event-driven or not if we're doing backtesting? So I guess event-driven means you have a tick coming in, and then you basically do an operation. A tick coming in, you do an operation like a buy or sell. So that's ideal if you're trading in a live environment, and even for backtesting is actually pretty good. But one thing that I wanted to do is to focus FinMarketPy more on doing research, historic research. So at the moment, it's more of a vectorized way of doing the backtesting rather than this event-driven. But hopefully in the future, I'll do that. So I'm going to show you a few demos now in Python. I also just got a quick question here. What percentage of my time is dedicated to data engineering versus data science? I think it depends upon the problem. Like if I'm using a small data set, you don't end up having as much, say, data engineering. But if you end up having a massive data set, you end up having to spend a lot of time to clean it, working out ways to store it, etc. So I would say it really depends upon the data set. But I'd say in general, I probably put in a lot of time at the beginning in the data engineering part in terms of working out how to store my data, etc. So now I don't do quite as much of that as I used to, because I already have my framework set up for storing data and the like. Okay. So I'm just going to show you a very, very simple example of how you download and plot data with FinDataPy. So here I'm going to use, let me just switch to the notebook. I think it's probably easier for that. Okay. So the first thing is I just want to show you how to download market data. So we import the various libraries, the various objects. So the market object, the market data request, market data generator. So with the market data request, we put the start date. So we want a week of data. The tickers, it's going to be euro, dollar. We want intraday data, we want FX data, the closing price, and we want it from Bloomberg. Then we actually instantiate the market object. We fetch the market and we give it our request. So if we do Shift Enter here, okay, let me zoom in a bit here. Okay, hopefully that's a bit easier to read. Okay, so that's actually downloaded that now from Bloomberg. So I've got my Bloomberg terminal running. Now, if we can now plot that using the ChartPy library here. So we basically say we want it to be plotted with matplotlib, and then we give it the data frame. Okay, there we go. So this is live data essentially. So we can see euro dollar. Euro dollar fell quite a bit just now, although it's been running over the past few days. If we want to change our data source, we can just do it with one keyword. So here I've changed it to Dukas copy. So it's a free data source for tick data. Change the frequency to tick. So underneath this, it's using a totally different API. But obviously, on a high level, we're just seeing it as this FinDataPy API. So I'm downloading data from the 1st of January 2020 to the 5th of January. So if we do Shift Enter on that, we can see it's downloading the data here. And this actually Dukas copy is free. So if you download this code from the FinDataPy website, you can run it and it'll be fine to run without subscription. Again, we can plot it. So you can see it's kind of easy to switch between the data sources. The next thing I'd like to talk about is my transaction cost analysis library. So essentially, transaction cost analysis involves looking at your trade data alongside the market data. So you want to understand how much you're paying for your trade. So you end up calculating metrics such as slippage. So that's the difference between your execution and the mid-market price. Also market impact, how much did the price move from your execution afterwards, and lots of other metrics. Essentially, you need several different data sets. So one is your own trade data to actually act as basically you want to understand how much that costs to trade, and then market data, which is tick data. And this will be very, very dense, large data sets. So essentially, you have a lot of heavy computation involved. It doesn't necessarily have to be complicated computation, but because the data sets are so big, you need to end up using a few tips and tricks to speed it up. So typically, what I've tried to do is to cache a lot of the market data in memory using Redis, also compressing the market data as well, and in some instances, trying to speed up the operations in Pandas as well. So here I've got a question about Bloomberg. Should I have a subscription or an API key? So essentially here, you don't give the Bloomberg API in Python API key. Essentially, you just need to have the Bloomberg terminal running on your computer, essentially, for that to work. There's also versions of the API that you can use on Linux machines, for example, which don't have terminals. So that's kind of more of a server API as well. But I haven't used. I've only used this. I've only used it through the context of the Bloomberg terminal. In terms of comments on market data, you do have variation from different data sources, and it can have a very big impact on your model performance. So one thing that I've done a lot of is developing intraday trading strategies for FX. So you might end up trying to use what is called indicative data to backtest this, and you end up getting very different results using indicative data compared to data which was actually tradable. You might not find this difference if using, say, daily data or weekly, etc., because the variation is not as much. But yes, you do find a lot of difference basically between the different data sets. So you do have to be careful about that. So that's an extremely important point there about that. So here, essentially, so what I'm going to do is I'm just going to show you TCAPI here. Okay. So I've done all this in Python. You can download this code. So here I've done this in Dash, which is a Python library. So let's say we want to look at trades between October and November 2017 for euro dollar. I'm using Arctic and I'm using Dukas copy data. So if I click calculate here, if I go into the background here, we can see that this operation was kicked off now on my Linux instance. So here it's plotted it. It took 3 seconds. So this is showing us all the trades here. We can zoom in here. We can look at the various orders that have been executed, redraws, and we can click on them. And the nice thing with Dash is all these operations, all these events can be trapped, like clicking, zooming in. So if we click here, we can click at the markout. We see the price before and after as well. We see the distribution of the slippage. So the slippage is the difference between the mid-market price and the and where we executed. So this basically just showing us the cost of our trading and also giving us insight into where we executed versus the market. I also wanted to give a quick demo of Excel Wings. So in this spreadsheet here, I can basically dump my trade data here, which I've dumped just now. If we run our TCA computation here, I'm looking at trade data between April and May 2017. I'm looking at euro dollar. I'm getting it from this data source and this database Arctic. Okay, it took 6.9 seconds and it's just executed now. So this is in GMT, that's why it's an hour behind. And then it's also created a PDF as well. So if we run that, let's run that. So it just generated this PDF. There we go. So it just generated now 3:25 GMT. So all this, I've done this with Python, basically. It's got charts here as well. I've generated from the analysis. So this is kind of the same analysis that we just saw in Dash. So I just want to show you how versatile Python is, that we can do all the different parts of the operation, whether it's doing the back-end computation, etc. Yeah, so what I've done is when I've profiled my code, typically I end up using PyCharm, and PyCharm has a code profiler in it, and it gives you basically a number of time you spent in each line of code. Also, if you end up using Jupyter Notebooks, there's also code profiling tools as well, and you can also measure the time it takes for code to be executed. So I have found just doing simple examples in Scifi, it does end up speeding up the code, but again, it depends upon your specific use cases. So I used the code profiler quite extensively when I was doing this TCAPI application to understand where the bottlenecks were. So in particular, the bottlenecks were actually loading the data from the database. That was one of the major bottlenecks, actually. So I spent a lot of time trying to cache that data. And also I distributed the computation using Celery. So if you ask to do computation for multiple tickers, essentially it will do it on different Celery workers. So there you go. And also it's dumped some of the results now on the spreadsheet here. So these are the charts, and it's dumped that on the spreadsheet from Python. And again, you can download all of this code from the GitHub site here for TCAPI as well. So if we go back now, so that's, I think we're running out of time now. So if I go back, and let's just talk briefly about the QDC. So the QDC is essentially the Quantitative Development Certificate with WBS training and Talesians. And essentially it gives you a lot of the fundamental skills that you need as a quantitative developer. And it's at an introductory level, so it doesn't require you to have a lot of programming experience. And it's designed by practitioners like myself from quantitative finance. We'll be looking at several different languages. I'm going to be teaching the Python for finance module, and Ivan will be teaching the C++ part. And then Paul will also be teaching the KDB part. So that's in particular looking at interesting things like manipulating high-frequency data sets. And these are the various modules here. If we have a look and just make that bigger. So we have Python for finance, C++, fundamentals and use cases from quantitative finance. Ivan is also teaching data structures and algorithms in C++. And then Paul is teaching KDB, and also a very interesting topic, the design of systematic trading platforms. And Paul is very experienced in that area. So the idea is you'll get a lot of different skills that you'll potentially use across your career in quantitative finance. So I do hope you'll have a look at that. And that's going to actually start next month. So I'll be teaching the Python for Finance first, and then we'll go on to the other courses, and that will be online as well. And if you've got any questions about QDC, feel free to ask me, or also WBS. So as in conclusion, we talked about why I use Python for finance. I've talked about many different Python libraries for data science. And also I've talked about developing libraries of financial markets. Also, we did a few demos, FinDataPy and also TCAPI as well. And again, all that code is on GitHub. And then finally, we talked about the quantitative development certificate, which I'm going to be one of the lecturers on. So I do hope a lot of you will take part in that, and I'm sure you'll enjoy the experience, and you'll learn a lot of good skills from that. I also got a quick question here in terms of the latest graph. Have I used the Excel Wings library there? I actually end up using the Plotly library to do the plot. But then I use Excel Wings to kind of paste it into Excel, essentially. That's how I ended up doing that, basically. And whilst I've used an example here using tick date, etc., you could do any sort of report you wanted in Excel or PDF as well. So that's kind of about it for the presentation. So in terms of software testing and unit testing, I typically end up using PyTest for that. So if you look at my TCAPI library, you can look at some of the unit tests that I've done here. So if you go to tests, Gen here, so you can look at some of the stuff that I've done on unit tests there. So are there any other questions before I wrap up and finish? Okay, I'll just give you 30 seconds for questions. But if not, then, well, thanks for all the questions throughout the presentations, much appreciated. I always find it easier to present when people are asking questions. So the recording will be available, and I know that WBS training will provide the recording for you. So if you've got any questions about the content, feel free to ask me, or if you want the recording, WBS should provide that. And thanks very much. Thanks very much for registering. There's obviously many Python libraries I could have talked about, but we had limited amount of time. So hopefully in the future, I'll be able to talk about a few more libraries and then in a bit more detail as well. So the QDC will start in June. So I can just show you the website here. So this is basically, it's in the next few weeks essentially here. So this is the QDC website. So in terms of costings, I think that's something that WBS can answer you on that. Okay, well, thanks again, everyone, and thanks for taking part. It was great to talk. So it's a bit unusual for me to do webinars, but I've been doing a lot more of them recently, and it's actually quite good fun. So thanks again. Thank you. Thanks.